Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the February-March 2023 paper from the Cambridge 9709 syllabus. This is the paper 1, the pure mathematics paper. And this question here is all about binomial expansion. So it says, in the expansion of x over a plus a over x squared raised to the power of 7, it is given that the coefficient of x to the power of 4 divided by the coefficient of x is equal to 3. Find the possible values of the constant a. So, one strategy could be to actually expand this for all of the terms, all 8 terms, and then see which terms will give you the coefficient of x to the power of 4 and which term will be the x term. And take the coefficients and divide them, equate them to 3, and then solve. But that would be very long-winded. So what's best for us to do in this type of question is let's see how we can identify what the term is going to be, which will have x to the power of 4, and what the term is going to be, which is going to have x. So when we do expand, normally, the way I like to do it, I like to use, I draw my 3 brackets first. The first bracket is for NCR. It will say 7 something, 7.1, 7.2, 7.3, up to 7.7. We don't know. I'm not going to put the bottom number yet until I figured out what it's going to be. And the second bracket is comprised of whatever's in the first, whatever the first term is. And the third bracket is whatever's, the last term, including the sign. If it's negative, I'll have to put the negative there. There's no problem. There's a positive. That's fine. Now, I know that there's going to be 2 powers here, and their sum has to be 7. So, you can have 7, 0, 6, 1, 5, 2, 4, 3, 4, 2, 5, and 1, 6, and 0, 7. This can vary between 7 and 0. This can vary between 7 and 0, but whatever they are, they must add up to 7. So whatever this is, that must add up to give you 7. So we can try to now figure out how we're going to end up with, on the numerator, x to the power of 4. Okay, so basically the powers have to be, when you raise all of this to whatever power is gonna come, and you raise this to whatever power that's gonna come, the x's have to cancel out such that you're left with x to the power of 4 on top. So we could do this almost by trial and error. Just, for example, if I put 7 there and 0 there, okay, and see, this is going to be x to the power of 7 on top. Underneath, you're going to have x to the power of 0. That's going to leave you with x to the power of 7. We don't want x to the power of 7. We want x to the power of 4. Let's say we're looking for the x to the power of 4 one first. Okay, that won't give us what we need. So we can cross it off. And we can say, all right, let's try 6 and 1. X to the power of this, if you raise this to the power of 6 and this to the power of 1, this will be x to the power of 6 here. And the denominator will be x to the power of 2. Because remember, you multiply the powers. Now, x to the power of 6 divided by x to the power of 2 gives you x to the power of 4. So that's what we're looking for. So this is going to give us the correct, this is going to give us the x to the power of 4 term. Okay, so we've got that one sorted out now. So what number goes in here? Well, I can either put 1 or 6. It doesn't matter. It will give you the same coefficient using Pascal's triangle. Now, 7c1 is going to give me 7. Anyway, we'll figure that out afterwards. Let me just write out the next bracket, and then we'll put the values in. So we're going to do the same process now. That's going to be 7c something. That's going to be x over a to the power of something. That's going to be a over x squared to the power of something. Those 2 numbers must add up to 7. So let's just carry on. Let's try 5 and 2. Now that will be x to the power of 5. X to the power of 5 over x to the power of 4. When you raise something to the power of 2 to the power of 2, you multiply the powers, you get x to the power of 4. And that gives us exactly what we want, x to the power of 1, which is an x term. So that's going to give us an x term. So again, I can put here 5 or 2, it doesn't matter. And I've got my, bracket. So now I can calculate this. 7c1 is 7. So I have 7 times. And this is going to be x to the power of 6 over a to the power of 6. And this is going to be a over x to the power of 4. X to the power of 2, sorry, not 4. A over x to the power of 2. Okay, and that will give us what we're looking for. Basically, you'll end up with the x to the power of 4. That'll be 7 over a to the power of 5. okay, because that's going to be a, and that's going to be 5. They cancel out to give you a to the power 5, right? So 7 over a to the power 5, x to the power 4 term, that's a coefficient x to the power 4. Okay, and for this one, 7c2, we're going to find out what that is. So we take a calculator, press 7, Shift C is this button which you have to access using the Shift button, the one above the division, NCR. So 7C2, and that gives us 21. So it's going to be 21 times, and this will be x to the power 5 over a to the power 5 multiplied by, and this is going to be a squared over x to the power 4, which will give us 21. Okay, and of course you'll have the x, and you'll be over a to the power 3. That'll be a to the power 3 because they cancel out to give you 3 in the denominator. So now we say the coefficient of x to the power 4 is 7 over a to the power 5, and the coefficient of x is 21 over a to the power 3. Okay, and we know that if we divide the coefficient of x to the power 4 by the coefficient of x, you end up with 3. Okay, so I know that 7 over a to the power 5 divided by 21 over a to the power 3, it must give us 3. We got to find the possible values of a for this to be true. So first of all, when you're dividing two fractions, you can change the sign and write the reciprocal of the fraction after the sign. Okay, and we can see here that 7 cancels with 21, leaving you with 3. And a to the power 3 cancels with a to the power 5, leaving you a to the power 2. So we're left with on top 1 over 3a squared equals 3. If we rearrange this equation, we can multiply both sides by a squared. So you're left with 1 over 3. 1 over 3 equals 3a squared. We can divide both sides by 3. So we're left with 1 over 9 equals a squared. So therefore, a is going to be the square root of 1 over 9. Don't forget, when you take the square root, it could be positive or negative. So we end up with a equals plus or minus 1/3. So those are the two values of a that we're looking for. It says find the possible values of the constant a. So you're going to have two values. You know that if you put instead of a 1/3 and you square it, it's going to give you 1 over 9. If you put instead of a minus 1/3 and you square it, it'll also give you 1 over 9. Minus 1/3 squared gives you 1 over 9, as does 1/3 squared gives you 1 over 9. So there's two possible values of a that make this true, either negative 1/3 or positive 1/3. So thus, those are the two answers for this question. All right, so saving a lot of time, by focusing on the term that you're looking for is way easier. And you can do that even by trial and error if you can't think, because it's not that many combinations that you'll have to choose. You know the one on top has to be the bigger number because it has to be, raised to a higher power than the one underneath. All right, and so you're going to have to use a bigger number on top. So you only have like 7, 0, 6, 1, 5, 4, and so on. Okay, 5, 2, so that they have to add up to 7. So if you understand how to, set up your binomial expansion using NCR, this makes this very, very easy. Okay, so that completes question number 6 from February, March 2023 on binomial expansion. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of binomial expansion in the playlist over here. I'll also include my binomial expansion material from the Edexcel board, which I have a lot of questions on that already done. And the playlist will be over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.